reaction I'm about to demonstrate now is the preparation of benzoic acid. To do this, we turn benzyl alcohol. So you see here is the alcohol group here. And what we're going to do is going to take off these two hydrogens here and put an oxygen on instead. And we end up with this structure here. So you see the functional group now has got the OH group with a double bond O. So this is an alcohol functional group. How we do this reaction is we have our benzyl alcohol starting material and we oxidize that with a potassium permanganate solution, which is here. It's a 0.5 molar potassium permanganate solution that I've already prepared. And then we react that in a conical flask along with some sodium carbonate, sodium sulfite and hydrochloric acid, all of which I have here in front of me. So to start the reaction, I'm going to put my benzyl alcohol, 1 milliliter benzyl alcohol into my conical flask using a dropper. That's 1 ml benzyl alcohol. I'm then using half a gram of anhydrous sodium carbonate, which I've pre-weighed in these sample vials. And to that, I'm going to add my oxidizing agent. My oxidizing agent is potassium permanganate, and I'm going to use 25 milliliters of potassium permanganate, 0.05 molar. I'm going to add that into the solution. And then this reaction mixture has to be mixed for 15 to 20 minutes at 60 degrees Celsius. I'm going to pop it in top of my water bath and then turn on the Bunsen burner. With constant stirring, let the potassium permanganate oxidize the benzyl alcohol. You may notice the brown colour of the potassium permanganate coming out. That shows that the potassium permanganate, the manganese is turning from +7 to +4, so it's oxidizing some of the benzyl alcohol. Ensure you keep the reaction mixture as close as possible to 60 degrees for the duration of this oxidation reaction. So the first thing we need to do is to cool down the reaction. So I'm having just a bath of water here. I'm going to cool down the solution. This should still be a basic solution, which I will check using red litmus paper. So I'm going to take a sample of the solution. And we can see how the litmus paper turns blue. My solution is now around 25 degrees Celsius, so I'm going to add in around 25 ml of hydrochloric acid to neutralize the base. With shaking, you get some effervescence, so bubbles of gas being produced, and then shake. To check we've added enough acid, we get some blue litmus, taking some solution, and we see the red colour of the acid, so we've added enough acid in at this stage. Here I have the sodium sulfite solution, and I'm going to add that in dropwise until the brown precipitate disappears. So keep adding, and we start to see benzoic acid precipitating. So you can see in our flask we have the benzoic acid crystals floating in the solution. We want to separate our benzoic acid crystals from that solution, and to do that we use a Buchner filtration apparatus. So to set up a Buchner filtration apparatus, we need to get a piece of filter paper which matches the same diameter as the funnel. Put your funnel on the top, then single piece of filter paper, wet the filter paper with the ionized water and place that over the holes. So now our funnel is ready for the benzoic acid to be filtered into. So when I turn on the tap now, that goes through the Buchner apparatus, the aspirator. That creates a suction which draws air through the filter paper. And then when I pour my liquid in here, the crystals should remain on top of the filter paper and the solution will go through. So you can see the clear liquid going through into the bottom of the container, and we'll show you in a second whether we've got any crystals or not. Swirl the flask periodically to try and get any of the crystals off the side of the buckler flask, off the side of the conical flask. And now we can see clearly when I remove the filter, we can see crystals or benzoic acid product on top of the filter paper, which we can dry and weigh to get percentage yield from the reaction.